jump to my introduction. And as an academic researcher, I think we need to start with where we are. Academics, we share ideas a lot more than we share code. It's slowly changing. I think that's probably the safest way to do it. Personally, I've been a user of open software, realistically, probably my whole career, increasingly, though, a contributor too. So I'm going to talk about my experiences and thoughts, start a bit about me, because I think it matters for why my experiences are what they are, a bit about the realities of computing in an academic environment and how we write code and so on, using open software, sharing open software, and then some reflections and lessons that I think would be useful for anyone that ever gets involved in academic code, but also for people that aren't doing academic code but have to handle academics that do code, because I think they both matter. But it was a nice quote that I found using ChatGPT the other day. The most widely used software in science today isn't built by software companies, it's built by the scientists themselves. And certainly in my experience, the really key software that I'm using now is built by the scientists that I personally know. So that shows you this level that's probably true. So a little bit about me. I'm a researcher in the Met department. I started research at the University of Reading in 2002. That was when I started my PhD. One could probably argue earlier in 2002 when I did my undergrad dissertation in researching an idea of could we do something? The answer was no, but that's not the point. My expertise is in rainfall and weather radar. Many of you, and when I say many, I probably mean almost everyone, because it got hundreds of millions of hits possibly by now, certainly in the tens. This video, people will recognise my hands turning a cup upside down, because 3 years ago nearly, we turned them up. We turned a cup over in the Harris Garden and demonstrated why the long drought meant that flash flooding was a threat afterwards. And that probably gives away that I've done a lot of sort of media and outreach stuff. So I'm kind of, that sort of thing matters. And I've won awards for public engagement in meteorology. But of course, I do a lot of coding, because as a researcher, that's where a lot of our data analysis is. And I thought it was really important. I should point out that in my entire career and pre-career, I've done an entire one module that had anything to do with programming. It was one undergraduate module in my second year, and it wasn't really programming at all anyway. Even then, it was numerical methods, and the practicals taught you the very basics of programming. I actually probably learned more programming in primary school than I did at university. So that probably tells you a lot about my coding training. It's almost entirely self-taught. But I use software all the time for data analysis, for data processing, and of course numerical modeling. I've never done the numerical modeling myself directly, but I use data from numerical models all the time. But I think the most important message really from this talk is that there are a lot of realities in doing research, and particularly academic research, when it comes to software and trying to do open software. As we've said, I was never really taught to program. The most basic programming taught me the absolute fundamentals. And I've got kids, and I must say I'm really impressed with how even primary school kids are taught how to program without programming, basically, like flowchart systems and so on, of how one would make a program, which is really nice. And to some extent, I can learn from them as much as anything else. It's a really nice thing. The other important point is that funding for research doesn't usually really consider software. It's very rare that software would be any kind of deliverable output within a research grant. It is changing. So there are now, software often will come up, but I have literally never at any point in my career been on a research grant where a deliverable output was any form of software, open or not. It's been data that's been generated from software, etc., but never the software itself. Now I've said that, that kind of leaves you with the point that there's never any funding for any time to make my software anything other than for me. So that means documentation. I don't have time to write documentation. It's never going to be high on my list. It's never going to be on the priority list at all, let alone it won't even make the bottom of the priority list. It won't be there. The other thing that sort of really matters is code efficiency. It's not really my target goal is to write good, quality, efficient code. My target goal is basically to get to my end result as quickly as possible, which, if I'm only going to run a piece of code once, doesn't need to be very efficient. If it'd take me 10 hours to make the code more efficient and it would save me one, it's not worth it. Now, of course, that backfires horribly sometimes, where you run the code. Well, you thought you'd only ever run a code once. You ran it once and you knew it was inefficient and it was taking 10 times longer than it should have done, but you're only going to run it once. And then some point later, you discover you're going to need to run that 1,000 times, and it would have been much better to write it better in the first place. But that's not the normal experience. The normal experience is get it going now, and as quickly as you can. It's going to have a limited use scale. So efficiency of code time versus efficiency of runtime is the equation. It's not just make it run as well as possible. And the other thing that's probably important is that rarely do we have time to do things properly. Even if we'd have been taught properly, we rarely have the time to do it. So we certainly wouldn't have time to write full documentation like you would with proper sort of software developers and so on working in the software industry will do. We probably don't follow the correct sort of formatting structures and so on that are sort of largely widely agreed. I know I don't. I have my own in my head rules of how I write things, and that helps me understand my own code later. But they aren't formal rules. They're rules that I've kind of taught myself over time, probably with a bit of input from people that have helped me in the past learning the programming. They have their own rules that I've kind of picked up. That's kind of where my realities come. So what we expect to happen and what the reality of what really happens aren't necessarily the same thing, much as sometimes we'd probably like them to be. Now, I guess I should come up to the why we should use open software, because I've hinted, but I'm completely reliant. What I do, my research day to day, is reliant on open software and open libraries. Because of who I am, I've learned over the years a whole bunch of different languages, and MATLAB, Python, R, PHP, and Fortran. I probably know all of those well enough that I could teach courses in them. So, of course, I'd be teaching them to academic scientists and not how to program properly. But that's kind of the position we end up in, and that's why I got taught like that. And I've learned to read a few more where I've had to understand how codes work, other people's code works without really needing to do anything with it other than just run it. So C++ is probably the perfect example. If people give me a C++ code, I can probably work out what it does, but I definitely couldn't write anything from the ground up. I personally use almost entirely Python 3 now, and PHP for anything I do web-based, which is not very often, but when I do, I taught myself PHP just because it seemed like a good idea. And I thought it was important to point out what the big packages I rely on in terms of really specific software are two Python packages. One is called PyArt. That is basically a very specialist weather radar module package for Python. It is based on sort of other pre-existing things like Xarray within Python, but without that, I would lose loads of time because it does a lot of the basic radar, weather radar stuff like plotting and basic analysis that otherwise I'd have to code from scratch. Now, the bad news, of course, is sometimes it doesn't do it in a way I'd like, and so I will change I will then edit them or completely rewrite them, but it's there as a nice starting ground. And then PyDDA is probably an even more important one in a sense. That's a package for generating grids and using radar observation data. It does lots of numerics in a very clever way, and using that, which is written by 3 people I personally know. It's open software out on the internet and well documented and so on. But their output, their deliverable from their funding, was this software being an open access, usable by other researchers. That's why that happened, and that is just incredibly specific. It would have been probably literal years to write that code if I'd had to write it myself. So I can only thank them tremendously for it existing. And of course, I'm using things like NumPy, SciPy, Pandas, Iris, Matplotlib. They're all sort of open libraries for Python that I rely on. So I thought we should think a bit about what matters to me personally and why I would use what software I do. The most obvious one is it has to be compatible with what I'm doing. There's no point trying to use something that isn't going to work. I've got specific data formats and so on that I might as well use software rather than having to hack around formats, use software that works with it. What would be really nice is if it had widespread use, particularly if it had local widespread use. If I have someone I can go and talk to and say, I can't make my PyArt grid format correctly, can you help me? If there is someone I can go to around the Met department, it's quite useful for me to be able to do that and save a lot of time. But actually, widespread use in the wider scale community is helpful too, because I know I will have people I can talk to and contact and will know the pros and cons of certain bits. Another thing that I find really helpful, and probably I've tried to put these in order of how important they are, is actually good working examples of things. A lot of open software comes with documentation that I could read through in excruciating detail, but no actual working examples, which in my head makes it harder to use. The example that talks through how to use it, to me, makes life so much easier to then implement my own versions of it. And that, I must say, is exactly where PyDDA, and this is off their own documentation page, you can see how high level PyDDA have an examples gallery that shows you how to use their package. And it's beautifully well written. It shows you the actual exact code they're using and the outputs, how to make it work. Another one is contactable authors, because I tend to be using software that's really specialized. Being able to talk to the author or email the author and say, I found this, is this behaving how it should do, or have I done something wrong? It's really helpful. And with the software I use, I do personally know the people that wrote it. What mostly actually since I started using the software, I've met them and I can use it, but that really helps that I can email them. And it also means at later points I can contribute to help improve this software. And then finally, clear documentation, which is only useful if I can understand it. And lots of times documentation will be so sort of, it'll either be really high level, so it doesn't tell me anything, or so low level, as it were, so in depth that I don't understand really the depths of what it's saying. So documentation that's aimed at me is kind of the important point, I guess. But next, I'll think a little bit about where we are in terms of as an author. As I've said, I don't code properly. I was never taught to, and I never really had time to learn to code properly. It's never been on my radar, I guess I should say, as a weather radar person. I think my code is fairly readable to other people that have learned my way, but I don't necessarily do things for the right way. I learned MATLAB and then moved into Python, which means I write Python in a very MATLAB-y way. It's not very Pythonic, as it were. So that doesn't help. And since the software isn't a deliverable, it's never been a desperately critical. I'm doing it basically because I think I should rather than I have to. But I do think that's important, and we'll sort of say why. So yeah, my feeling is we should, as a research society, share software. So much time is wasted making the same thing. So let's not do it. The other thing is, of course, that we don't really necessarily have any resource to share software. It's not just time, you have to put it somewhere, etc. So we think about it, but I am motivated to publish software, as it were, to make it open. I think there is generally an academic culture shift towards openness, certainly in Weather Radar, my own really sort of specific niche. For the last 10, 15 years, there have been a few big names pushing hard to make software and data much more open. And I've been in support of them all along. So I think it's my duty really to try and help push that along. It saves time. It makes work people do a lot more reproducible, and it gives you great opportunities for collaboration. So I think there's benefits to me as well as to the community if I do so. So how have I shared software? And basically, I guess I've not gone to the full level of using Git, etc., GitHubs and so on to share openly. What I have done, I've put things out into the public on my own website. I've put code there you can download. I've gone into what I'm going to call semi-public for data. I put things on the CEDAR archive. So that's a big UK national data archive of weather radar data and other weather-based, climate-based data. You have to apply for an account to get it, and then that will be it. But basically, it's pretty much public. As long as you're doing research work on it, you can get that data. And then, of course, I've also done the sharing in the most informal way by request. Somebody asks me for something I've written, I send it to them. And particularly when our group within sort of when working as a team, that's useful. But also just people know I've got software that does something, they will email me and ask. And I will basically always send them the software. But we're still there with those realities. There's a time investment to make code shareable, and basically that will be off my own back to do that. I certainly live with the fear of people will find bugs that they will then judge me for my bugs and my untidy code, because I can assure you most of my code probably will have flaws and so on, and it's certainly not very tidy. The other thing, of course, is it's important to point out that the value of doing open software, there is just it doesn't exist in academic reward structures really. So the fact that I will probably become a contributing author to PyDDA and maybe PyArt doesn't really. The only benefit really is that there's probably more people will know my name within the industry. It's not anything else. I thought I'd give a few examples of what I have done shared sort of in my software world. So about 15 years ago, so fairly early, probably even during my PhD, I wrote some code that loaded the very bespoke radar data format from the Met Office. And then it worked only in MATLAB. I converted it to Python about 10 years ago. And at the time, that was about when the Met Office were bringing in a new data format, new weather radar system. It was basically based on the old format, but an updated version. So I wrote a Python code that loaded that. I also amended the MATLAB one so that it still worked in MATLAB. Initially, that code was literally just for me. I never intended it to be a public code, but soon other people in Reading started using it because they would say, well, I know Rob can load Met Office data because I've seen him use it. So they'll ask me if they could have my code. And of course, then I get to the awkward, I probably ought to at least write some comments in to make it a bit more helpful or show you how to use it. Then after a while, I was asked by somebody at the data center, well, actually, could we put this live to live with the data so other people can use it? And I think I spent a couple of hours making a few more comments in the document in the text, but I didn't write a documentation. It's just literally code comments that tell you what each thing does, its step does, and so on. So that if you do need to change it, you can. And it's still there. So I wrote that code 15 years ago, the original version. It still sits in the with the data, and I believe people are still using it, which is quite exciting. I'm actually currently writing a newer, better version of it because I can use different things, and now I need it in Python 3, not 2. But that sort of shows you how code has worked. It's just shared next to the data. It's not in a proper code repository or anything. And my experience is this kind of code sharing is really common. Share stuff that starts initially with just a small handful of people becomes widespread. And I do occasionally get emails. It's very rare, but occasionally I'll get an email from someone who has found something with, or they found a problem that they're actually, almost every time it's a problem with the data rather than the problem with the code that they find. But I do get an occasional comment to thank you that exists, but that is literally the total extent of that one. The other one that I thought was important was a really public example of sharing. I did a sort of short study of forecast data comparing the University Atmospheric Observatory to weather apps. And because it was going to make a newspaper story, I wanted the software to be available publicly because I wanted it to be completely traceable. I wanted full openness on what I'd done, how I did it. And so I literally put it on the web, on my website. And I thought it was really important. I actually wrote this note almost exactly 6 months ago. This project's been written and coded in Python 3. If you download you can download the Python code here. It was written by me, an academic, not a programmer, mostly in my own time. It's functional but not beautiful. It doesn't follow conventions other than my own very loose ones. It's not well structured or commented, but it's provided for transparency and perhaps use. And I think that's a really important point, really. I don't think this code is brilliant. I don't think this code is perfect for sharing at all, but it works. And I'm more open by sharing it, and I've given it a Creative Commons license just to protect myself a little bit with it. No one has ever contacted me, despite the fact that this website and so on made it onto a number of big newspapers and so on at a busy time of year for such things. Literally no comment. I should have checked the analytics to have a look, see if it's actually ever been downloaded, but no comments whatsoever. I've never been contacted on it, so who knows? I think I'll go into a few reflections and lessons. I think the most important one is actually be kind to yourself when writing software. I've got a long enough career now that I come back to software that I wrote years ago occasionally, and I would say document as best you can. And I'm realistic that I don't have time to spend a day writing the full documentation, but at least write comments of what sections of code do, because when you come back to it in a year's time, you can't remember. So comments that at least there are hints and reminders will really help. And the other thing that's probably most important to me is version control. I've had to learn this one the hard way a few times. If you don't do version control, you're going to end up regretting it later. Things go wrong, your code stops working, etc. It's very helpful to be able to revert back to a definitely working version. It's something I do now, and I do think that using Git or similar sort of systems for doing this kind of version control is probably worth the time investment learning, because they can save so much time later. The other important one is that sharing code doesn't mean it has to be perfect. It just has to be usable. I think that's really important in academia. Other academics that you share it with live in the same world we do. They know the situation. Most academic code is messy. It's okay. If I get code from other people, it's also messy. And almost anybody that's written that code is willing to help. It's rare you'll ask for help from someone and just get a hard no. So that's useful. And most importantly, I think the science community benefits when we all share and learn together. If we're all going to win if we share, so I think we should. I guess my closing thoughts then. Open software is going to join up with open data and open publication in sort of basically opening science out, making it more shareable and open, both in terms of being sort of more, I'm trying to think of the correct word here, it's suddenly gone out of my head, where it's more reproducible, but it's more sort of, there's less hidden. And certainly in meteorology and climate, so often you're part of the system, etc. What your results are real. Being able to sort of say, well, this is where it's all come from. Go investigate yourself. You can follow it is really important. And will further science faster as a community. If it's hundreds of individual efforts. That will be much slower than a whole community moving together. But it does require people to think as a community, not individually. If we all take individual self-interest, it hurts the community, it doesn't help. So I've got some thoughts for users. If you're using open software, report issues, particularly if you're sure that you know what happens, and suggest improvements. If you can fix the issue, suggest the improvements to the original. I have fixed problems in that code that I shared on the data loading. People have reported a problem. I have gone, so it is, gone and fixed it. But also credit the developer. Nothing annoys me more than somebody who I know is using my code and doesn't mention it in any way. They don't even say thank you to me in person. And as a developer, share anything really that you think other people might use. I think that's probably the most useful. I probably should be doing myself it more in a sort of easier access way, but I think I'm doing better and I will improve as we go on. I guess I should say, I'll say any questions, but I think try and make them questions that are quite specific to my experience, because Maria and I could do a sort of joint questions at the end of what Maria says.
As well, to recognize some of the issues around research computing that we're facing. So I wanted to start with my mission statement, which is to make our research computing resources and our support that we have more visible across the university. I think it falls under the radar sometimes. I think especially when it's not acutely needed, the awareness isn't often there, and I would like to change that, because we do have research computing resources that can be very helpful, hopefully are very helpful, and I also recognize that there's a broad spectrum of requirements. There's lots of different flavors of research computing across the university, and I'm using the word research computing in a very broad context. So this can include coding, this can include using research software, this could include numerical models, so anything that has, or web hosted, web resources, databases, any of these things as well. So it's a very broad topic. And it's not there's no simple answer to the support that we can provide, the support that we are providing. So we and we meaning those of us who are involved in research computing support, being at DTS or across the university, we aim to foster that collaboration and knowledge sharing, so that those who need help and support can be helped by those who have experience in research computing, open research computing, research software, and things like that across disciplines. So to give you a little bit of background about why, who I am and why I'm doing this, I am, my background is, I'm a research software engineer. And research software engineering is something that is kind of a mix between research and software engineering. So something that sits between more technical IT jobs. So a software developer, a programmer, or somebody who's looking after research or software systems, and also somebody who has a research background. So there's various different flavors of research software engineers, but it's kind of a broad catch-all term. So somebody who sits between these two disciplines. And my background is in meteorology here at the University of Reading, and I have a PhD in oceanography and postdoc in ocean modeling. So I have done lots and lots of research computing in the academic part of my career. So anything from writing software to numerical modeling to data processing and visualization. So I do have got some of the experience that I think can help in supporting the research computing that we do here at the university. So I identify as this research software engineer since about 2018, and I'm a member of the Society of Research Software Engineering. Since then, I'm involved in regional and national research software engineering groups. So we have Research Software Engineering South, which is founded by Reading, and ours London as well, which is our neighboring group. So there's a lot of related webinars, meetings, knowledge bases that can help with some of these questions and issues that we have that are not just Reading centered. So if there's any interest around that, then by all means do contact me. But now I'm part of the digital research computing team here at the university, and my very main favorite thing to do is research computing training. So trying to teach and help and support with anything that covers the fundamentals of getting started in research computing. And then it's also cluster computing, so looking after our software and code on our cluster, the Reading Academic Computing Cluster, the RAC. And I'm part of the Open Research Action Plan, so I'm also very interested in research computing in the context of open research and what it means. We have so in our digital research computing team, we have Kelsey, who's our manager. Then there's also Pavel Stasiak, who's the cluster research computing lead, and Paul Heaton, who is a research software engineer. And we have a very broad range of knowledge and expertise around research computing and the aspects that I've mentioned. So there is a lot of support available in us, in the team. So this slide is a bit of a brainstorm. I wanted to just sort of connect open research and research computing. And I think that, I think that research computing is a fundamental pillar of open research. And I think a lot of the words that we use to describe open research can be applied to any research computing discipline. So things like open source, open access, reproducibility, shareability, all of these words that we use as keywords in open research do apply to research computing. So reproducible research software, shareable research code, openly accessible data, anything like that it's intimately linked. And I think often, so Rob also mentioned that research software, the software isn't a deliverable, a key deliverable in research output, but I think it really is key, because it ties in with shareability, with reproducibility. And if research output needs to be reproducible, then the software and the code that is written to produce this output also has to be reproducible. So it's a very, very strong connection between these two terms, I think. I think Rob has been very honest in his talk about the challenges that are associated with research computing, research software. And I myself, like Rob, I'm completely self-taught. I have no formal training in any of the stuff that I've done, be that in my PhD and going forward to my postdoc. I've learned all the coding initially myself, and I think that's very common. We don't really have too much formal training in these computing fundamentals. And I think also that's still quite often overlooked. This is something that I'm very passionate about trying to change, so that at least the sort of gateway into research computing, so understanding the systems, understanding the initial steps that you need to do in order to access the software that is required to process data, the tools that are needed to work on the research project that the person is invested in. I think this fundamental training is it's important to spend a bit of time on this, because I think that the following steps will be a little bit easier, hopefully. And the other thing that we do see as well, and I'm including our own DTS documentation, my own documentation as well, is that documentation and user guides are often too difficult to follow. And by difficult, I mean it does depend on the level of knowledge that is initially there. But I think that sometimes research software documentation is just given to students who have to just make it work somehow. And it's actually very difficult to overcome this hurdle when documentation seems very, very complex and isn't easy to follow. So if that becomes a hurdle, just simply following documentation, I think that's one of the common challenges that I'm recognizing. The same with command line computing. We do a lot of command line computing in research computing at the university. And I think initially that is, for somebody who is not used to this, it can be a big hurdle. So I think fundamental training in command line computing languages and command line access is very important. The other reality is that I think the digital research computing support isn't very obviously accessible sometimes. Could be not sure who to ask questions, what help is needed, who can help. And I think we can change that as well. And another thing I wanted to say is there's a cultural change that I would like to achieve, if that is possible. So this hesitation to ask questions. I think Rob mentioned this in the context of fear of being judged. I get a lot of messages where it starts with, I'm really sorry if this sounds like a very basic question, but I'm sort of, it's not a basic question if it is a big hurdle to overcome for somebody. So I never try and see it in the sense that something is so very basic that it shouldn't be asked. It should absolutely be asked. And if, you know, as somebody who's self-taught, it's not ever obvious in the beginning what is a basic question and what isn't. And I think if we can remove this sort of hesitation and just encourage asking questions, especially at the beginning, I think we are going to work big steps towards achieving this literacy in software encoding, in reproducibility, creating all of this open environment. I think, Ian, have you got your hand up? Is there something that you want to say now?
No.
Okay. Yeah. So this comic here is actually quite something that I've experienced a lot. So getting something to work and not knowing why something works. Does that mean that is it really working? Because if we understand fundamentals a bit better, then, and if we understand why a code works or doesn't, that will help another step in achieving this reproducibility, this shareability, this literacy that we are trying to foster. So how can we foster these improvements? I think I recognize very much what Rob has said, that it is very tricky to always work at best practice. There's often absolutely no time to invest the time in writing, even for your future self, to become a better coder or a more open research computing expert. I often think that I could invest the time in writing something, a piece of code that I know will do the task that I need to do right now if I have to repeat it a few times for the future. And often then I recognize it is really hard. You can't often put in that work. And I think if we're honest about this, and we can't become perfect in academia with achieving this openness in our software, what can we focus on that helps immediately? And in my opinion, that is spending time on fundamentals and the foundations. So understanding the system that I am going to use to process my data, to do my research computing, and understanding the research software that I'm going to be using for this. I think these are big steps to help with this problem. And the other thing as well is commenting in code. When documentation is tricky to write, and I write a lot of documentation. I'm trying to write this for those who use our systems, but I recognize that especially if it's documentation when you know maybe there aren't that many users of the piece of work that I'm doing, but for your future self, writing comments in the code or writing comments in software or processes helps a lot, because what seems obvious to you now when you're writing this is completely not obvious to you even in a month's time. And I have done this so many times. So I think commenting little notes really go a long way when documentation isn't possible. And seeking training and help. So not hesitating to ask questions, attending some of the training that is available, looking to get help, bespoke help from us. And with that, I can go to the key that I want to deliver in this talk, which is what support do we have available from DTF? First is, I will go through some of these links at the end of my talk, so I would, but just to mention briefly, we do have a website, which is our academic computing website. There's a little screenshot on that slide. And on there we collected, it's sort of a hub for a bit of everything. We are working towards improving it all the time. And on there we have all of the documentation that is available for our systems. We also have the training that is available. We collect some of the training resources and links that we think are helpful. It's a growing section, so we are putting a lot of work, and we will be putting a lot of work in growing these resources. We also have revised a research computing services section and on top desk, so on the help desk. I'll show that in a moment as well. So some of the things like training or also requesting the resources that we have available for research computing, hopefully they're collected in a more accessible way. And this includes just asking questions too, because not everything is an incident or a problem. A lot of the time it can simply be a question. What do I do when I need to do this? I'm not sure about how to do this. Can you help? Anything that is a bit more vague, so as a way to just ask us questions too. And we have drop-in sessions every second Wednesday afternoon. So Pavel, Stashak and I are running these. We are there for at least 2 hours every other Wednesday. And we are trying to help with anything that can't be resolved in a ticket, anything that is better in person, any questions that are on the use of our systems, on the use of software. If anything is unclear, if we can explain something in person, anything, there's a very, very broad range of things that we are trying to do in these sessions. But anybody at the university is invited to attend without any sign up, and we're there to help. Hopefully we can help, but we're trying to help with some of the problems. So just to close, some of the a roadmap of things that we're trying to do or will do in the future. The first one is that we are always continually trying to enhance our online resources. So that is our website that we are trying to grow, put more documentation on, more training. And also, I recognize Rob said that version control is important. We are not pushing this enough in our training, so more resources around Git and version control are in the works as well. And with that, we are expanding training opportunities. So there will be more frequent training sessions, and we're shaping this by demand and requirements. So this can be centered around intake of new students for PhD and master courses. They're often quite popular in learning the fundamentals of systems and maybe some basic command line training and computing languages, things like that. So there's more in the works and how we can deliver more training more effectively. And also we have launching soon as a research training community of practice, because research training isn't just undertaken by the digital research computing team. There's lots and lots of different ways that this computing training is provided, and we're trying to create a hub of collected resources across the University of Reading where training related to research computing of any type can have a home. And further in development, we have a digital research community. So that is headed by Kelsey, our research community manager, and it's aiming to be a collaborative space for anything that revolves around research computing. So this could be community of practices, it could be interested groups, it could be, it's for those to share expertise and tools and best practices around research computing. So if there's interest in anything around that, please do let me know. as well.